Hello ladies and gentlemen, and welcome to the LSEG data library tutorial. This is going to be part one, going through Python fundamentals to start with, and then part two is going to go through Python fundamentals as well, but we're going to go through libraries, and then moving forward onto the LSEG data library for Python itself, which is the wrapper that is a little bit more complex. Without further ado, let's go on forward into Python and what it is. For those of you who don't know, you can download Python onto your own computer, onto your own machine on python.org. As you can see, it's quite simple. You have your documentation and things such as download. If I were you, I would go ahead and go for a Python 3.12. That's the latest version. I like the ones since 3.11 because you have your type hints in there. If you're interested in that, I've already made a video on it, and we can touch on it towards the end of these tutorials, including it with the LSEG data library. But for now, we're just going to skip over them. We're not going to be too concerned about them, but go forward with the simple stuff. Now, when you are coding in Python, what you can think of is just a notepad. So here I've got a notepad open. It can be something else, write a Word document, anything like that. And what you do when you're coding is that you're just storing characters, a string of characters into your computer. So let's say I say hello, that's something I can write in there. And my computer is taking in the characters that I've entered into my keyboard, displaying it in the order that I've put them in. However, if you were to do something like 1 + 1, press enter, it's not going to give you 2. All it's done here is that it's giving you the characters, portraying them in the way that it should with your computer, and that is not an interpreter. And that's the difference between you working on your notepad, for example, and with an environment that is for coding called an IDE. Now, don't worry too much about what an IDE is. It's basically an interpreter. It's a environment whereby if I was to write 1 + 1, it's going to give me 2, and not just the string of characters in question. Now, I'm not actually going to go through Python and downloading it and things like this in front of you because we happen to have an interpreter, which is to say that environment I spoke of within Workspace in of its own. So if I was to do this, here it is. Now, if you were to go into Codebook yourself in Workspace, or if you were to go in Workspace yourself anyway, this is not what you're going to see. You're going to see something like this. You're going to see a home page of some kind, maybe with some news, and you might be looking for Codebook, which is that environment I spoke of. In order to find it, all you have to do is go at the top right there in the search bar and type Codebook. There you go. If you were to click on there, you will see something like that. As a matter of fact, what you will see, you'll see this. And on the right, you'll have your notebooks that you can create. Don't worry too much about what a console is, and you can create all the other types of files, not just Python files, such as text files. Now, I don't actually use this launcher too much, but you can go ahead and use it if you want. I normally just go straight through the browser. Now, file browser can be found on the left here, so I can toggle it on and off by clicking on the file browser button to the top left, and I can create some new files here, right-clicking on the navigation side to the left. So here I can create a new folder, for example. Let's call it documents, and I can create some new files within that document on the left. However, be careful because there will always be some documents here, some folders here that already exist. For example, examples. Anything that has underscores before and after them when you first start Codebook are folders that exist within Codebook and that we have created for you. Now here there are some examples, there are some guidelines and things as such. I would strongly advise, by the way, that you go within the examples. There's some really good, interesting stuff in there. Let's go through get data, for example. It's some of the simplest functions within the LSEG data library that you can use right here. But let's not jump the gun. Let's stick with our code right there that I have created for you. So let's discard these savings, these changes, and go for the LDLib Python tutorial 1. Okay, what we're looking at here within Codebook is called Jupyter Lab. So it just happens to be the name that has been given to this type of environment where you can code. And within this environment, you have 2 types of cells. So let's get rid of that file browser. Let's make things a bit bigger, actually. Oh, no, they're as big as it can get, really, for now. What I have here are 2 types of cells. So if I was to click to the left of the cell in question that I have in mind, if I was to double click, I can see exactly what's in that cell. So I have something that's not Python code. This is called Markdown, and we call them Markdown cells. And they're a bit different to just, for example, the Notepad. Here I just wrote 1 + 1, and this is all I see. I just see the characters. With Markdown cells, I can have some titles. So here, for example, this is a 3rd level title. If I was to press Shift Enter, it's going to run this cell and show me this, what I've written, in a markdown way, and it does this with this third level title right there with comments. But if I was to look at the top here, for example, I've only got one hashtag in front of that line. It's telling me that it's a level 1 title. Obviously, this is the highest, the best type of title you can have. If I was to press Shift Enter, it's going to run this and show me that title in big letters. That's not the only thing you can do within Markdown. Again, let me double click in here, and I can see that I have my level 2 title here, and I have my hyperlinks. So I can have some hyperlinks with open square brackets, close square brackets, open curly brackets, or like normal brackets, in order to have then my my URL in there. I keep saying that I'm pressing Shift and Enter. Now I'm going to be talking through quite a few shortcuts here in this tutorial, but I also wanted to show you the straightforward way of doing things. Here I can change, or toggle, I should say, between the Markdown and code cells, and here I can run my cell. So if I was to click on there you go, it's run my cell exactly in the same way as if I was to press Shift Enter. You're going to have access to this notebook. So again, FYI, what you're looking at here is a notebook. You're going to have access to it and you can read it on your own time, but I'm not going to be reading it out loud word for word. I'm just going to be going through it with you a bit quickly. Okay, so here before, up until now, we had some markdown cells just showing some information, but we are going to go forward with Python. So here what I have is a code cell. I can create code cells by clicking to the left of a cell that already exists. And by the way, there'll always be a cell in a notebook. I click to the left of such a cell, press B, and it's going to create a cell below it. I can press A, it's going to create a cell above it, and I can press D twice to delete them. So let's do that right there. And if I was to write 1 + 1, just like I have on my notepad, and run this, so again, that's Shift Enter, it's going to give me 2. So this time it's actually compiled this information, it's run my code, and it's given me a result. This is the return, and it's 2. Now that's quite simple to see to start with, but as you can see, I've been working on this notebook before. This is cell number 56. It shouldn't be, it should obviously be 1. Let's clear our kernel, let's clear our memory, and make sure everything is clean. So restart kernel and clear all output. There we go. Here you go. So now we can just get a fresh start. Let's run this piece of code again. So here we can see it's a cell number 1. This is quite important. So you can see that now I could tell in which order the cells were run. You'll see in a second why that's important. We don't only just have characters that are run within our code cells. We also have characters that are not run if we tell the interpreter not to run them with a hashtag at the start of our line. These are comments. So we don't only just want to have characters that are run, we also want to have comments because maybe we have a very complex piece of code and we would like to explain our code to human people actually reading and using our code, and we'd like to go forward explaining this without it being run by the interpreter. If I was to go here, for example, and remove the comment hashtag, if I was to run this, it's going to give me an error. It's going to say this makes no sense to Python. Indeed, it wouldn't. I'm going to go at the start of this line and put my hashtag. You don't have to put a space, by the way. It's just a common thing to do. And then what it's going to do is going to ignore that first line and only run that second line, where it says 2 + 2, and it's going to give me 4. Okay, these were for comments. We don't only have comments that you can use within Python. You could have pieces of code that are a bit more complex than what we've had up until now. All we did were some very simple mathematical operations like 2 + 2, 1 + 1. But where coding really shines is where you can actually allocate memory. So here, this is what we're going to do in this cell right there. We're going to allocate the memory for the information 3. So it's just an integer, it's just a number 3. And we're going to say to the computer, I would like the character A to now mean 3. So let's do this right here. If I press Shift Enter within this cell, it's allocated the memory wherever A is, whatever A is, it's said now it's going to be 3. I can code A as 3. When I say allocate memory, that's actually what's happening within your computer. What you're telling your computer here with this equal sign is that you're allocating a piece of the memory within your computer to that integer 3. So if I was to run this next cell here, it happens to be just a little piece of code that shows you where that memory is. What this means is that within that specific address, you are going to find 3. It's quite simple, really, but it's a bit like, I don't know, 1 London Street. It's an address that your computer can read, and you can follow that address to find the information within that address. Don't worry too much about hex and ID and things like this. We're going to go through this next. However, I wanted to quickly go through types because we spoke about 3. 3 is an integer. So here, if I was to do type, A is going to tell me, okay, int means integer. But there are many types of objects within Python. So here, if I was to allocate a new object, so by the way, when we allocate information to a character, so here it was A before, now it's B, we call them objects. And there are different types of objects. So here I can write type B, and it's going to say it's a float. I can now, what is a float? How is a float different from an integer? Well, it's just the decimal point numbers. So here I dot 0, therefore it's telling me it's a float. There isn't that much more information between 1 and 1.0. You can put more complex floating point numbers, decimal characters after your integer, so 43.91, and it's telling me yet again, yes, it is indeed a float. You don't only have just integers and floats, you also have other things such as strings. Strings is quite simply just a series of objects that are kept in order. So here I have 1, 2, 3. I am delimiting my string with square brackets, so open square bracket, close square brackets, and I have my objects here delimited with commas, and I'm saying I'd like D to be that list. And again, if I use type and then put D inside of my function type, it's going to tell me what object type that is, and it's a list. Fair enough. We also have strings. So strings is just a series of characters. Let's write hello world right there. We're going to say that E is hello world. What is E? Well, it is a string. Let's have a look at what E is, and we can just write E within the cell, press Shift Enter, and it's going to show it to us right there. And it's hello world. Note that this is just a series of characters. It's capital H, small e, all the way, including that space right there. Now, this is important. You need to remember the spaces is not going to add them for you. And you can also use these objects now that they're in memory together. So we had B and C, if I remember correctly. One of them was a float, therefore it's going to convert the entire thing into a float. And we're going to tell Python, whatever A was before, I don't want it to be that anymore. I would like to instead allocate this object within A. And it's done that right there. A, which previously was an integer, if you remember, now is a float. Let's have a look at what that was. So here C was 43.91. What was B again? I think it was an integer. It was 1.0. No, it was a float. By the way, it would work. You could add an integer and a float together. It will give you a float as a result. And what do we have then as A? A is going to be the sum between the two, 44.91. Okay, moving forward, we can put things together, as I said. We can put objects together with functions. Now, I've sneakily already showed you several functions, but here we can have an operator, and that's the operator here is plus. Plus is just a function. It's the sum function. So here we can do a plus b is going to sum the two together. You can do a times b using a star instead of the plus. We can have two stars next to each other, giving you to the power of. I've just written here right there with a comment. Note also that you can have comments not just at the very start of a cell. So let's something like this. You don't have to have it just like this. You can also have it at the end of the line, just like I showed you in a second. And we can have a look at these. You can also use the types as functions. So here we had operators as functions. So the multiply, the plus, the minuses. But you can also use native Python functions that already exist in there. So here, if I was to write int, open bracket, put the object that I have in mind in there, close bracket, is going to change whatever is within those brackets into an integer. So int is a native Python function changing an object into an integer. If I was to run this here, it's going to tell me 43. Now, if you remember, if I was to run all the way back up there, there we go. C was a floating point number. We had some decimal points right there. Whereas here you see it just says 43. Let's say I'm not interested in the floating point numbers. Let's say I used someone else's function and it's returned me some number, and I'm not really interested in whatever the decimal points are. I can change it into an integer right there with the function int. Moving forward, we can have a look at yes, what I did here is I have shown you the function int. However, I did not allocate memory to the object C. Here, the object C has not changed. So if I was to run this, we can see it's still 43.91, regardless of the fact that I ran this function. In order to overwrite this object so that it is not a float anymore and it becomes an integer, I have to write C equals int C. So you can see that you can allocate memory to an object that already exists using that object that already exists. It's a bit complicated, but you've got it right there. It's quite simple when you see it. If I was to run this, now it has overwritten the memory allocation specifically made for C with this integer 43. I've showed you operators that work with numbers, and to be honest, we're going to be using operators and functions mostly for numbers, but there isn't just that. There is also, for example, strings. You can add two strings together. What's going to happen here is that it's going to append them. So it's going to append hello and then world. Again, don't forget the space. It's considered as a character. If I was to remove this, it's not gonna add it for you. You can do this right there, and again, append them together. We can also use functions within functions. So here I've got print A. All that's going to happen here is it's going to print me that object. Whatever A is going to show it to me. That's what print means. And I can also use the function type inside the function print. That's what I'm doing here. And what I'm going to do is I'm going to ask the computer, what is the type of B? Please show me with a series of characters, which with a string, show me what type B is. And I can even use operators like plus, for example, within another function. So here I have a function print, and I'm going to use the plus operator inside that function in order to see all of this. So I've got hello world, comma, you see how I've got my comma, space, hello. And it's showing me that right there. I've got my print A, so it's just going to show me A, print type B, so it's telling me, okay, B is a float, and here I have my last line right there. Moving on swiftly forward, now we're really doing some serious stuff. We are defining our own functions. So up until now, we only used functions that already exist within Python. They're called native functions, but you can create your own. So here, by writing def space and then the name of my function, I can create my own function with my own arguments. So I can put my arguments within brackets. So here my arguments are going to be x and y. They're separated with a comma. At the end, I'm going to have my colon to say I have stopped defining the metadata for my function, which is to say the name and the arguments. I'm going to start defining my function and explaining what my function is going to be doing after that colon. And I'm just going to say, okay, return x times y. And that's what it's going to do right here. Whenever I run this, it's going to return the product between x and y. Note, by the way, that we have the tab at the very start telling Python, telling the interpreter that we are still defining our function, right? We are defining this function that I have created. I've named it created function, created underscore function. Yeah, don't forget that bit. Each character within Python is crucial. And it's telling me with that tab here that I'm defining my function and I'm going to be returning that product. So let's run here right there. And yet let's use that function, created function, where x, which is my first argument, is 5, and y, which is my second, is 6. It's giving me 30. Now it's a bit complicated, but I really wanted to speak about docstrings here right now because it's something that we need to know about when we create functions. We spoke about comments at the very start, which are lines of code that are not run. They're only just there for human eyes, for people to be able to see and understand something new about the code that is not to be run by the computer. And we can do the same thing within a function that we are defining with something called a docstring with inverted commas. Now you need 3 of them, 3 inverted commas at the start and at the end. And whatever is in between these inverted commas is not going to be run by the Python interpreter. It's going to be ignored, and it's just going to return whatever you have at the bottom. So again, I've got my tab here telling the interpreter I am still defining my function, and it's telling the function return the subtraction between x and y. Why would you have docstrings, right? All I'm doing here is I'm explaining what my function is doing. I have created a function called subtraction. I am saying here, oh, hello, this is what my function does. It gives you the subtraction between the two. What are the parameters? I've spoken about arguments, but within the definition of a function, they're called parameters. So what are the inputted parameters of my subtraction function? It's x. I'm saying that x is an integer, or, by the way, just FYI, this is what the little line means in Python. It means or. So it's integer or float. It is the thing that we're going to be minusing from, and then the thing we're going to be minusing with, that's going to be y. What does it output? What does it return? It returns an integer or a float, and it's going to be the subtraction between the two. This is quite important because it's there for people to understand what your function is doing. Now, if I was to run this, you're going to tell me, what's the difference between those things and what we did before? Why didn't I just put everything in with hashtags at the start? I think if I was to do this, there you go. If I was to press Control / it's going to automatically comment out whatever line I have on my cursor. So why don't I do that? Why don't I do this here instead of having my inverted as well? The whole point of this is to allow people to use the help native Python function with your function that you've just created in order to be able to see those doc strings. By the way, that's what it's called. It's called a doc string. So here, if I was to write help subtraction, it's going to show me all that text that I have written right there for others to see when they use my function. Because if I was to use the function subtraction x, y, how do I know if it is x minus y or y minus x? I don't know. You're going to have to explain it to me within doc strings, and I'm going to have to use the help function within the function you've just created in order to find that out. So yeah, you really hammer this in at the very start so that everyone uses doc strings and explain their functions correctly. There was one last peculiar function I wanted to talk about here today. If I was to remove actually the print function, so let's do this. There we go. And there are f strings. F strings are just like strings. So if I was to do something like that and run it, it's going to just run the series of characters I have written. However, if I put f at the start, all of a sudden it becomes a bit of a quirky function, and it takes whatever is in curly brackets and turns it into a string for me to see. So here, let's do type A. If I was to Control C, A, and then Control V, Control Enter, and it's telling me float. Okay, that's interesting. But what if it's just telling me float? I don't know what float is. I'd like to know that A is a float. Now I can use an F string and those curly brackets to say object is of type, and then I have my type right there, and the value of, and it's going to say the value of A right there. So if I was to do that, it's going to show me 44.91, and I can put it within my F string. That's all it is. It sounds a bit silly, but when you have maybe 1,000 lines of code and you're going to print something, let's say you print A, you're just going to see this. You're going to see 44.91. You're not going to know what it means. That's why you use f strings as an example. That's an example of how you could use f strings in order to give yourself context for what is being printed. Okay, yet another extremely powerful piece of coding just in general, but it's very simple in Python, is if-else statements. So here I have if a is equal to 44.91, print this. What it's doing is that it's just logically going through the logic. It's saying if that object, a, is indeed equal to that floating point number, then run this code. And again, we have this tab at the very start, just like we did with the functions that we defined, in order to tell Python that we are running this code if and only if this logical statement is correct, is true. Notice also that we used equal. We did not say equal because I was not telling the interpreter to allocate information within A. I was not telling, okay, I'd like A to be 30. That's not what I was telling Python to do. I was not creating a new object or overwriting an object that already existed. I was instead saying if A is equal to something else, then run some code. That's why we have two equals instead of one, to delineate between allocation and logic. You don't only have equal, you have larger, equal to, you have smaller than, and you have also a not equal to. So here, for example, is A larger than 44? Well, it's 44.91. Therefore, yes, it is larger. Is A smaller than 44? No, it's not. Therefore, it's not going to run this piece of code. And again, by the way, I just wanted to show you that you don't only have to have one line of code. You could have several. If I was to go at the end of this line, press enter, it's going to automatically keep that tab there in order for me to continue writing my piece of code within the logic. And if I was to write print, I said yes before, didn't I? Let's print no, why not? And then run this, and there it goes. It's not run any of the code right there because that statement is incorrect. Now, what if you have a cascade of logic? Maybe, okay, yes, if A is unequal to 44.91, then print this. However, otherwise, do this. And that's what this else statement is there for. If A is not equal to 44.91, do this, else do that. It's literally that simple. That's why I really do love Python, is because it's something you can just read and understand just off the cuff. It's all very close to English. Okay, these were if-else statements, and we spoke about lists before, but I wanted to quickly go through the types of objects you can have within lists, and that's all of them. You can have pretty much all objects usable within Python. And here, what I'm doing is I'm creating my list with my square brackets. So, open square brackets, and I'm going to put a string as the first object. So the first object is going to be A. I'm going to have 1, which is an integer, as the second. Then I'm going to have that floating point number right there. And I'm even going to have a Boolean. A Boolean is true or false. And in Python, by the way, it starts with a capital number. So true with capital T or false with capital F. And I'm just going to finish it like this. And I can run this and see my list. And here it is right there. By the way, I wanted to go quickly through how you can iterate through a list. So let's say I was given a list in Python and I'd like to use the second element of my list. What I would have to do is I would have to write the name of the object, which is list in this instance, open square brackets, and then write the number, the position of that object within the list. So I said I wanted the second one, didn't I? I want the second object. So if I was to write 2, run this, it's giving me 10.2. It's not giving me 1. And the reason for this is because within Python, everything is 0 indexed. I say is everything. That's not strictly true. Most things, specifically the native things within Python, are all 0 indexed. So actually, we're going to start at 0. 0 is going to be A. Then if I was going to go for 1, it's going to give me 1. So you can see that the first element is actually the 0th index element, and the first element, or the second element, is going to be the first indexed element within my list. And we can go on like this. And by the way, you can also do this the other way around and go with -1. So if I was to go to -1, is going to give me the last object, which is false. And I can do -2, give me the second to last object, which is 10.2. Okay. We went through lists where you can iterate and where you can collect an object via its position. But what if I'm given a list and I do not know in which position the information I want is? Let's say I'm given this list and what I want out of it is 10.2, but I don't know if it's the 0th element, the first element, the third element. I have no idea. Instead, what you can do is that you can use a dictionary. A dictionary allows you to specify the object you're using within a dictionary, not with its position, but with a name. So here within my created dictionary, which I've defined with curly brackets, I can have my first object that I'm going to call call_pr, and the second one that I'm going to call put_pr. Let's imagine that there are call prices and put prices. And here you can see that I've created a list. So the first object within my dictionary that I'm calling call put dict for my dictionary, the first element is going to be a list of integers, 1, 2, 3, and my second one is going to be put prices, which is going to be 10, 20, 30 inside that list. So you can see we've got a list within a dictionary. We've got several lists within a dictionary. You can have a dictionary within a dictionary. You can have a floating point number within a dictionary. It really doesn't matter. Here, even I don't have to have a string to call that name. I could actually have one. It would make it a bit redundant. Why not use a list, I guess? But there you go. You can do this if you want to. I can press Control Z on my keyboard to go back a few times. There you go, to when it was called call price. I can run this, and now what I've done is I've created this dictionary and I have allocated information within this object for that dictionary. So I can call that object and I can call, well, the dictionary object, and I can call specific objects within my dictionary via their name. So here I'm going to look for call prices. Here I'm going to call for put prices. I spoke about the fact that you didn't have to have lists within your dictionary. You could have just a floating point number. Why not? Let's do this. And it's going to give me 1. And you can also add to a dictionary that already exists. Let's say I want to add the model. It happens to be that I've got my call and put prices, but I would like to know how you got those call and put prices. You can do so by adding a key. So this is what this is called here. The call price, the string, call price, and the put price string, they're called keys. And I can select the key within my dictionary, and I can create a new key within my dictionary with square brackets in a very similar to the way I invoked the object in question. So here, instead of invoking an object, the object put price, I am creating a new one with the key model, and I am allocating the string Black-Scholes model inside that key, inside my dictionary. So here I can run this, and let's have a look at our dictionary now. We can see we have all the information we were after. Now, this is just a little trick for you, by the way, because I use this quite a bit. Here we have our dictionary in a string format, which is perfectly fine. But I believe that if I was to do print, it's not done it. Never mind. Normally, what I wanted is for it to go to the next line with tabs. I'm going to find a way for it to work for you later here. Moving swiftly onwards, we can use for loops. Now, this is the other piece of a Python code, Python coding that is extremely powerful. You can iterate through basically anything, but here we're going to keep it simple and iterate through a list. So here I'm going to say for I in my list is going to be 2, 3, 4, and 5, do something. So I'm going to, it doesn't have to be I, it could be index, which is, by the way, why everyone uses I. It could be ABC. For ABC in 2, 3, 4, 5, do something. So let's keep it with I. I'm going to have an object. The object is going to be called factorial. It's going to start with 1, and I'm going to say to my Python interpreter, please loop through that list and multiply whatever factorial was before by that object in that list. So I here is going to be 2, going to be 3, then it's going to be 4, and then it's going to be 5. And notice that we are multiplying factorial with this, and factorial keeps changing. So factorial was 1 to start with, then it's going to be multiplied by 2, so it's going to be 2, then it's going to be multiplied by 3, and it's going to go on like this. And then we're going to print our factorial in order to be able to see it. So let's run this, and we've got it right there. So here I've got my factorial, which is 1. I'm multiplying it by 2 to start with, so it's 2. Then I'm multiplying it by 3, so we've got 6, then 24, then 120. We've created our factorial right there. You can also create list comprehensions. Now, let's say that you wanted these things. So here we've got our factorials, but you want it within a list. Maybe you want to use it later on and you want to refer to a specific element within a factorial a list. Well, you can do so with a for loop. So here, for example, I have created a list with a single element. That element is an integer, it's 1, and I've called that object factorial. And again, I'm going to be looping through that list, 2, 3, 4, and 5. For I in that list, append the list that already exists, called factorial, and add this thing here. So what is factorial -1? So we spoke about -1. -1 is the last element within our list. So if I was to press Control Shift minus, it's going to split the cell wherever I had my cursor. And if I was to run this, it's going to say, okay, allocate the integer 1 as a list for factorial. Let's have a look at the last object within factorial. It's going to be -1, of course. Now, there's only one object in there. So if I was to do 0, it's going to show me the same thing again. But I just wanted to show you what -1 did, because if we move on forward, we're going to append that list, to add another object to that list with that last object in that list, and then multiply it by I, and then let's have a look. Let's print that factorial to look at it. Let's run this. You see we've got 1, 2, then we're going to add 6, then 24, and then 120. This is going to be our factorial list at the end. Now, if I was to comment this out, so Control / and run this, we got our factorial, and our last object within the list has changed. Now it's 120. Wonderful. That was a bit tedious. We had to run how many runs of lines of code? 1, 2, 3, 4, 4 lines of code just to have a list of factorials. It's quite a simple task. Why do we have to write so many lines? Well, the reason is you don't. You could use something called list comprehension, and that's what we have right there. In one line, you can do what we've done above in 4. Here, instead of a factorial, I have a number, whatever it is, let's say 0, and I'm going to add something to it. So let's say I don't want to do 1, 2, 3, 4, 5, or 0, 1, 2, 3. I want to have 10, 11, 12, 13. I can do that right there by adding 10 to whatever I is. So I'm saying for I in range 10, do I plus 10. Now, for those of you who don't know, range is basically just a list starting at 0 and ending at whatever you've got right there. So if I was to do this, it's going to tell me what range that is. However, what's interesting to look at is the fact that for I in, no, of course not. We have to start here. It's going to start at 0. Remember, I've said that everything is 0 indexed in Python. Okay, that's fine. So it's going to start at 0, but look at this. It's also ending at 9. It's not ending at 10, and that's because lists, range anyway, in Python are always exclusive with respect to its upper limit. So this upper limit here is 10. It's going to be exclusive with respect to 10 right there, and so it's going to show us 9. Notice that there are 10 objects within that list, right? Because we did not go all the way to 10. That's true indeed, but we did start with 0. So we added this 0 at the very start. We removed the 10. in total in that list, we have 10 objects. And that's what we're doing right there. So basically, we could have done something like that. Here, we could have done, okay, for I in that list, please show me, or please add an object in that list called I plus 10. So if I just do this, we have it here. Perfect. However, if I was to go back and put my range, is going to do the same thing right there. Perfect. I have to quickly just go through Lambda functions. I don't use them very often, but they are sometimes extremely useful. So here what we can do is that we can create a function in one line. So before we had to do def, and then we had to create a name for our function, and then the arguments within that function. We can do all of this right there. Now, don't worry too much about the underlining that's in blue and all these prompts that come up when my mouse moves over things. It is extremely useful, and I will be using it in the future, but for now we don't have to worry about it too much. So here what I'm doing is I'm creating a new function. I'm going to call that function add. So as you can tell, it's going to be adding numbers together. It's going to have two arguments A and B, comma separated again. Colon is there to say that now I am explaining what my function is doing, and what my function is going to do is that it's going to add the two numbers together. So I've got A and B, A plus B. Run this right there, then I'm going to say add 1 and 100, and it's going to give me 101, as you can see. Again, don't worry too much about this one. When it's usable, I'm going to tell you. I just wanted to show you very quickly what Lambda functions were. We've got, oh yes, and you can also use the functions that you've created within your list. So here I've got my Lambda function add, and I can do that right there with my range. And here we've got something very similar to what we had before with our 100 right there. And yeah, you can have your Lambda inside your list straight away. So instead of creating your function and then invoking the function within your list comprehension, you can have your Lambda function written directly inside the list comprehension. So if I was to run this, you see it's run the x to the power of 2 for each I within that range. And it's right there. Again, don't worry too much about this right now. It's going to be useful in the future, and I'll show you that there and then. We spoke about, obviously for loops. So for I in a specific list, do something to that list. And I also wanted to quickly speak about zips. Zips are basically just several loops within one. So here I'm saying for I and j within those two lists right there, I would like you to iterate between the lists to run this piece of code. So here I've got my print, and I've got my f string that I've spoken about before. And what it's going to do is that it's going to start the loop and say that I is 1, and it's going to say that j is -1. That's how it's going to start. And then it's going to say that I is 2, and then j is -2. It's going to go through that loop, and then at the very end, it's going to do the same with 3. So if I was to run this, it's going to print those right there, and you can see what's going on. However, notice that it's always going to go with the shortest list. So here I've got -1, -2, -3. If I was to do -4, nothing's going to change. Reason is there's only 3 elements in the first objects. Therefore, it's only going to go through these 3 elements. It's going to go through any further elements inside another object. You can do this both ways, by the way. So I had one more object in my jth element here, but I can do it right there, and it's going to be exactly the same thing. It's going to just pick the shortest one and iterate through them one by one. That's what we've got right here. All right, we're going to be speaking about libraries in the next video, but I wanted to very quickly show you the most important one, or the most used one anyway, with data science, and that's pandas. I know it's a bit of a funny name, but here pandas is a data frame library. And up until now, what we've done is that we've created our functions. We've used the functions native to Python. We've got our own stuff right there, but we can use functions created by someone else. And that's where Python really shines, because it's all about open source. It's all about some great code that was written by some extremely clever people out there. You can take it and use it yourself. And I've got it right there for data frame management. So here I can run this piece of code. If I did not have pandas, so if I did not have that library on my own machine, I would have to run this right there, pip install pandas. Pip install is a Python command that tells Python, the Python interpreter, to go and fetch that library inside a common repository out there on the web. So obviously you need to be connected to the internet, and it's going to go and fetch pandas, and normally it's going to fetch the latest library available for that library. Again, it's a funny name, but it's there right there. Then you can import that library with that line. Here, all I'm doing is I'm reading a very quick comma separated value document that I've got on codebook. It's somewhere in there. It's where my Python code is running. I can run this right now, and what it's doing, there you go, it's read my Excel sheet, my comma separated value sheet, and it's put it into a data frame. I've got it here. So it happens to just say 1, 20, and 30. It's a very small Excel sheet indeed. I can also create my own data frame without an Excel sheet next to my Python code. I can do so with the function data frame. So you see it starts with capital D and it's got capital F inside pandas. So here now what we are doing is that we're using modules inside libraries. So I'm using the library pandas. I'm then using the module, well, actually I'm using the module pandas, and I'm using the function data frame inside that module. What's the difference between a module, a library, and a function? In truth, there isn't really any. A library is just an enormous module in which there are many other modules and many other functions. So here I'm using the function data frame inside the module pandas. That function takes a few arguments. Here there's only one. It takes the argument data. And in order to define the data inside my function, I'm using a dictionary with those curly brackets. And I'm defining my columns, column 1 and column 2, and I'm using lists for my data inside my data frame. And I'm going to do all of this, and I'm going to call my data frame df1. So if I was to run this, here it is. I've got my first data frame using pandas with my 2 columns in my data inside right there. You can do so several times. So here I've got my df1, and you can create other data frames with the same functions. But every single time, if you had to write pandas, and there are other libraries out there with longer names, it'd be quite long and a bit tedious. So you can actually shorten the name of your library with simply just the as. So if you were to do space as, and then whatever you want to shorten your library with, you can do that right there. And pandas is pretty much always abbreviated with PD. You don't have to abbreviate it with that. You could do something else. So here I'm going to import pandas as PD, and I'm going to use it right there. So here what I'm doing is I'm using the data frame function inside the pandas library. But let's say I call it ABC instead. So I can go right there. I can import pandas as ABC and run this. What's going on here? ACB. Obviously, it's not ACB. It's going to be ABC. Run that, and it's going to work. So you can name it whatever you want. However, there are some ways in which people code in order to be able to read each other's code. So if I was to do pandas, boom, 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 and we have our data frame right there. Pandas is quite useful, and it's used by the amalgamation of people online because of the very useful functions that it has. Because what we have right here, this df2 is now a pandas object. It's a pandas data frame object, and you can use that object with very many functions. So here, for example, I can use the function sum, and it's going to sum up each column. I can even plot, so I can have a graph out of the very simple information that I've got inside my data frame. Okay, I wanted to stop here. I just wanted to show you very quickly how you could import other people's functions that they have created, but let's stop there in order to then really dig deep into libraries in the tutorial 2. This was great. In tutorial 3 and onwards, we're going to be digging really deep into the LSEG data library and use everything that we've spoken about today going forward to create some analysis and workflows with your data in the London Stock Exchange Group. All right, I look forward to seeing you again, and have a nice day.